Okay, guys, so what we're going to do today is I'm going to walk through the notes on balancing a chemical equation. So this is really important. Biggest thing that we can do is practice this, okay? Second biggest thing is we just got to understand what the purpose is. So we want to have the same number of each type of atom on both our reactant and our product side. So remember, our reactants, okay, our reactants are just going to be what go into our chemical equation. Our products are going to be what come out. Okay. So basically, our goal when we balance is we just want to make sure we have the same number of each type of atom going in as we have coming out. Now, why is that? It's because our reactants are what turn into our products. Okay. And so we just want to make sure that that's balanced. This satisfies the law of conservation of mass. Mass can't be, or matter can't be created or destroyed. So we just got to be able to keep track of it. Okay. So our rules for this are the only way we can balance an equation is by using coefficients. Okay, so let's start with our basic equation that we've been talking about. Okay, so we have hydrogen gas, which is H2, plus oxygen gas, O2, is going to give us H2O. Okay, so what we notice, our first thing that we always want to start with is split this into our reactant side and our product side and figure out how many of each type of atom we have. We can just make a little list. So over here I have, okay, I know I have 2 hydrogens and I have 2 oxygens. Okay. Now when we look at our product side, I still have 2 hydrogens. However, now I only have 1 oxygen. Okay. And so that's where it's like, okay, we need to balance this. Okay. So our first rule with balancing, we can't change any of the components in our chemical equation. Okay. So what that means, the 2 biggest things that we see is people want to add subscripts. You cannot change the subscript. So they say, oh, Mr. Hartman, you're so done. This is so easy. All I need to do is add another 2 here. Can't do that, right? We can't change what we are working with. Okay. The other thing is we can't put coefficients in between atoms of a molecule, meaning this hydrogen and oxygen are bonded. I cannot put a coefficient in between them. Okay, that doesn't work that way. So those are really our only rules. Now, what we need to do then is we say, okay, I need to balance this. I need to get another oxygen on this other side. But what I need to understand is that means I need to add an entire water molecule. And a water molecule consists of 2 hydrogen atoms and 1 oxygen atom. Okay, so we can kind of think of that as like that's our puzzle piece. That's what we have to work with. So if I want another oxygen, I have to add an entire water molecule. Okay, now we can see I now have 2 oxygens, which is great, but I also have 4 hydrogens. Okay, so from there we say, okay, now I need to fix my hydrogens on the other side. Okay, so same thing over here. H2 is our puzzle piece. O2 is our puzzle piece. So if we need to change anything, we have to add an entire O2 molecule or an entire H2. In this case, we just want one more, H2 molecule. Okay, so now if we count these up, I have 1, 2, 3, 4 hydrogens on this side, 1, 2, 3, 4 hydrogens on that side. Okay, on my reactant side, I have 2 oxygens, 2 oxygens on my product side. Okay, now how do we add these coefficients? We just simply count the number of boxes that we have. So I have 1, 2 of my hydrogen gas boxes. There's my coefficient. I have 1 oxygen box, which we could put a 1 there. You don't really have to. Okay, and then finally over here I have 1, 2 water boxes. Okay. All right, so that's kind of the basics. So what I want you guys to do when we come back, take some notes, add this to your notebook. Remember, diagram it out. Draw what your molecule looks like, put it in a box, because then we know we have to add that entire molecule each time we change it or add a coefficient. All right, goodbye.